This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seberg and I'm your host. Today I'm going to be talking to Coskun, I hope I pronounced that correctly, Islam. He is the head of collective intelligence engineering at Sandvik Manufacturing Solutions. Coskun and I are going to be talking about Gen AI for CAM systems. Good morning. Hello, Coskun.
Hello, Peter. How are you?
I'm fine. Did I pronounce your name correctly?
Yes, Coskun, it's pretty close.
On the foils that you were using, there was I think, a way to pronounce it. Good. Let's start with you, please, introducing yourself to our listeners.
Yes, this is Coskun Islam. Everyone in the company call me by Josh as a shortcut. Yeah, I've been with Sandvik a little over 6 years, and I work in a division basically that works in between different brands in our company. Sandvik Manufacturing Solutions owns different CAM companies, metrology companies, and some other solutions. So we own Mastercam, Cimatron, GibbsCam, Vericut, Metrolog, QDM, 3DCS, and some other solutions. Basically, our division, I directly work for CTO. We work on projects, a bit more cloud-related, also a bit more future-facing around AI. And nowadays, we work a lot with generative AI, how we can enhance customer experience, user experience around our manufacturing software, how we can embed knowledge to our products. That's what we do at the moment, pretty much, along with the other engineers in the division. So our team works like as a collaboration team, you can call it. So we have certain skill sets that's useful for everyone. And then with different brands, we solve different engineering problems. So that's what I am doing, who I am a bit at Sandvik. Originally, I'm from Turkey, and I've been around the globe a little bit. So I lived in Canada, now in Sweden. I was born in Istanbul, so I traveled a bit.
Very good. I'm going to be asking you at the very end to give us a global perspective, number 2, and number 1, to tell us a little bit more about your team. But we're going to be moving into what you just already introduced, Gen AI, generative AI. Now, Coskun, you and I, we did not meet, I'm sorry to say, at the Industrial AI conference that took place, what was it, 2 months ago, I believe, organized by Hannover Messe in Frankfurt. Robert and I were the co-organizers and co-moderators, and I was moderating while you were presenting. So, and we didn't meet. I'm sorry. We'll do that sometime face to face. But at least here we are meeting in the digital space, so to say. So let's start at the beginning. If we say Gen AI for CAM systems, or maybe more general, talking CAD, CAM, CNC. Can you tell us what these acronyms are? And telling you to start with, I actually studied computer-aided design, computer-aided architecture design, but that's a long time ago. So I'm very much looking forward to the next half hour, also to understand from you what probably most likely has been changing. Nevertheless, as an introduction, what do the acronyms stand for?
Yes, for the people who are not familiar with manufacturing world and design world, let's say, computer-aided design is CAD, and it is the technology that we use to design and engineer different products, basically. These software systems, it's our digital development platform for physical things. We can call it like our aircrafts, automobiles, cell phones, laptops, everything, buildings designed there nowadays. And computer-aided manufacturing, on the other hand, stands for CAM. It's basically you have the design in hand. Now you need to convert it to a physical thing. And how do you do that? You use different manufacturing equipment. We call them CNCs, which is computer numerical control machines, but I'll come to that. So in CAM, basically, we take this digital design that was prepared in CAD and translate it into manufacturing instructions for machines to understand. So for metal cutting machines, for example. So we take the design and we design how to produce it, how to manufacture it in computer-aided manufacturing software, generally for machining, but also for additive manufacturing as well. Additive manufacturing is also nowadays more and more embedded into it as a hybrid technique. And computer numerical control machines, basically, these are robots, but big robots, heavy robots, few tons, that can cut metal like a sculptor. But in this case, it's the sculpting happens by means of a code, which we generate in computer-aided manufacturing software. And then we carve metal from metal to create the final shape like a sculptor does, based on the design that was provided from CAD. So that's what computer numerical control does. I hope this is good enough, high-level explanation.
It is most certainly. I've always asked why we maybe are still, so to say, calling the CNC machines, specifically knowing where the terminology comes from, computer numerical control. But you explained it, I guess, where it comes from. And I think most of us will have heard, but thanks for just reiterating computer-aided design, computer-aided manufacturing. So, talking of, as I said, I'm looking forward to hear from you, maybe indirectly, what has changed. Talking of changes, what has been the main change from the time, CAM systems came to market. And before then, maybe as far as the worker-machine relationship, can you talk to that? What was before CAD-CAM? And what is today, as far as we look to exactly that relation of the worker standing in front of the machine as it was before and how it is today?
Yes. At the early days, of course, everything was manual and mechanical. So the amount of information that we needed to interact with was limited, and the designs were not that complex. So an operator ran the precision, pure mechanical metal cutting milling machine, let's put it way. Let's take it as an example, or a turning machine, and running it according to the measurements that is specified on an engineering drawing, that which is on 2D, and that those drawings were made by hand back in the day, and the machines were run by humans by measuring every bit and every tiny bit of the produced component along the way, and the precision was much lower, much higher compared to today achievable precision in terms of what we see today, like in terms of tolerances. So like what I mean by that, today we can produce things maybe 1/10 of your hair thickness, like to down to that level easily. And back then, we maybe more common to see it was 5 times that at best. And then today we are at the extreme level. Today, what happens? The machines became computerized. Designs became so complex, no longer humans can program them anymore, or like create them by manual steps. So we need an algorithm to process the design geometry to be able to create the manufacturing instructions for the machine, the code to execute, to carve the metal out from the initial metal block. And what happened also along the way, automation levels increased. And now, instead of one person running one machine, and thanks to automation, one operator can run whole manufacturing cell by him or herself, just making sure everything is running smoothly and doing maybe more creative things around the machines, more problem solving when a problem arises, rather than pure labor, which was before, and a lot of manual steps. So this is the main change, I would say, that's happening. But also the amount of information, of course, we need to process on the shop floor increased significantly compared to before. And it's at the borderline where we have so much information, but we have very much difficulty how to relate to it, how to navigate it. It's just bordering the limits of what our brain can handle. So we are not able to analyze with our brains anymore the amount of information on the shop floor. So we need a lot of computer systems, software, and nowadays AI. That is also a big aid coming up. So this is the main difference, I would say. I elaborated a bit, but I think this will give people the picture.
Yeah, I think it's important to realize and taking us with you. So we will be talking about the role then that Gen AI can play now. So we can just kind of start thinking together with you what the activities, what the use cases, the applications of Gen AI may be. Maybe you want to share with us which are the main production-related challenges that we have today or that we have had since we have been working with machines.
Yes, of course. One of the number one challenge, I would say, is in manufacturing. The demand for produced goods is increasing, but also customization requirements are going up. Like people want different things. You want a different car, other person wants a different phone, and things like that. So there's a huge pressure on original equipment manufacturers to reduce their design to manufacturing cycle times. But how do you do that? Like if there are lots of expertise required in between steps and also like lots of complex dependencies, for example, to produce something, you need to fix the material, you need to fix the machine, you need to understand, okay, how do I do the work holding on the machine to produce these components step by step? So it's never produced in one step. And how you design things impacts its manufacturability. So this interactive dependency can make it or break it, or can accelerate or decelerate it, how you can produce something. Another thing is that, like on computer, when you design something, everything looks like nice. You analyze, maybe do some simulations and such. But in real life, there is so much variability, huge variability. Like our materials vary, our machines vary, our tools vary. So nothing is same in terms of components we use. There's always a fluctuation in their performance. For example, you buy a material, its strength slightly varies, but that slight variance can impact the scrap rates. It's to that degree sometimes. Or how hard you can push your machine to produce the component, how fast or how slow, the batch-to-batch differences in material. Or I buy cutting tools, they wear out, but they can wear out within a ballpark. Maybe your machine gets worse and your cutting tools, for example, that carves the metal, the sculpting tool basically, wears out faster because your machine has a problem now. But you don't know yet that problem has grown that much. You just learn it when you start observing problems. So this brings a lot of experience requirement on the shop floor. So it's because since there's this much like complex dependencies and variances, finding skilled labor is a challenge, or educating the labor fast enough is a challenge for the shop floor needs. And also, no matter how skilled people are, we are humans. We do mistakes. We get exhausted. Not a day to day. We are same, right? And our output is not always consistent. There can be many things that contributes to this when we are adjusting things around the shop floor. So this is also another thing, that the quality variability due to human factor, and not just the physical environment. And what else I would say? Another challenge, maybe the last challenge, maybe we don't pay attention to it at the moment too much. We always talk about production efficiency, productivity, but we need to pay attention how we are taking care of the world. That's also another aspect that we need to pay attention. And our brains, its information processing capability, without having good digital tools around, is not enough to optimize to take care of the earth. That's also another problem that we need to think deeply. So how we can make our production practices more sustainable. That's only possible.
So many issues. Yeah, thank you. And sustainability is the final one, customization, the first one. I thought back of when Industry 4.0 was kind of introduced. I think it's meanwhile 11 years at the Hannover Messe. I was exactly there part of the smart factory at that time. Customization, as you say, everybody wants their own version of their car, of their watch, of whatever. So many, and a couple of other many issues. In comes AI, generative AI, Gen AI. So how can Gen AI help address these issues? And when you give us a couple of examples, maybe you also want to tell us what exactly you mean when you say Gen AI as a subset, so to say, of the bigger AI, artificial intelligence.
Yes, of course. When we look at the journey, like the machines, they were manual, as said. The automation level increased as automation level increased throughout the recent history. Like let's take it from 70s up until now, the amount of information we created increased significantly, and the complexity increased as we talked about. And imagine this information like a haystack, okay, haystack of information. And generally, to solve a problem, you're always looking for a needle in it. And generative AI, kind of you can think of it as a magnet, as a one important perspective around it. Like, so it's the magnet to find that needle in that information stack. It can help us to navigate these complexities, and we can create knowledge products, not just information. So we can turn information into knowledge. So today we have is a lot of digital systems, but that require also a lot of expertise to run. And they are information systems essentially, and human is the glue in between them. Generative AI can be the navigator between these digital systems, which generates a lot of information, and find that specific information that we are looking for and optimize it. So this is maybe, to me, the biggest immediate application area of generative AI, turning information into knowledge and capturing our capabilities, some of our human capabilities, to turn information into knowledge and basically digitize it in generative AI systems so that people can reach the expert knowledge much faster and accelerate their journey. So imagine imagine having a lot of navigators basically around the shop floor like this. So generative AI in that regard, its application can be in design stage, design for manufacturability. You have maybe a Gen AI agent that helps for that, or for example, another step, I designed something, I checked its manufacturability from design for manufacturability. And then now I want to create the manufacturing instruction and design a manufacturing process. Maybe I have a bunch of generative AI-based systems also interacts with this manufacturing process planning software, where generative AI, again, brings in expert knowledge or aids the human in multiple areas, much like GitHub Copilot. You can think about it. Also, in that context, there also human is in the loop, but Gen AI is helping you to access to the expert knowledge. Maybe you are not that experienced developer, but you get tips and tricks that might be given actually by an expert to yourself. And in a similar sense, we can think about it at the high level, generative AI as a navigator of this information complexity at the beginning, but then, of course, as it evolves, creating different systems based on it. Yeah.
Yeah, it's a very nice image you're painting there in my brain, so to say. Gen AI as a needle in the haystack finder, managing complexity and eventually turning information into knowledge, and then going further. But I guess you can, if you want to share now, but at least in the course of our discussion, an example, but assuming that the general solution being, as you said, rather than taking care of any of these issues you mentioned before, you can now then, is it correct, just ask the LLM basically to find the needle, and finding the needle means whatever it is, look for dependencies, shorten the cycle. So is that the idea? Basically start asking my Gen AI in the form of a large language model, I guess, whatever it is that I need.
Large language model is one piece of the puzzle, actually, when we think about it. It's from generative AI perspective, because we are thinking already about creating also some other generative AI-based systems that helps in design, for example, and also simulation of manufacturing processes and suggesting manufacturing parameters. So it doesn't necessarily need to be LLM as a like language model, but using the same maybe mathematical principles behind the scenes. But another generative AI system. But LLM, what it does actually, the beauty of it, it revolutionizes. It will potentially revolutionize how we interact with our software. Instead of having these so many clicks that we have today to get from A to B, LLMs first, the interface, as you described. I ask something, it is the interface. It can convert my natural language instruction into what computer can understand, and maybe I can create some behind the scenes, some algorithms, turn that natural language instruction into another function call or software system, bunch of function calls to interact with software system. So LLM you can embed a lot of, like you can fine tune it to understand certain context and such, a certain language, yes. But the beauty is just the UX revolution part, I would say. Like, yeah, exactly. And it has two sides actually. Yes, it has a lot of information around it. It's not maybe intelligence like we think of it, but it's some sort of like different way of, let's put it that way, intelligence. Not in a sense that we have it, but we can say that it's a different form of intelligence, maybe not human intelligence, but it's just helps us to navigate like this. And LLM is very important part. But the bottom line is that we are thinking about generative AI a bit broader, not just LLMs, but design context, manufacturing parameters context. So it can be a parameter space that we turned into generative AI, but we give the context to it. This is my production context. Here, what are the parameters? But like imagine a model designed like that. And then it's a generative AI model, but for manufacturing parameters.
Very good. So Gen AI is more than, although the LLMs may take a central role, it's more than the LLMs. Now, assuming that this is all leading us towards, autonomous, lights out factories from human in control, as you just said at the beginning, the human standing in front of the machine, more towards autonomous. Can you share with us? I think you've been doing some research, or at least personal, discussions, how your customers see this road towards more autonomous manufacturing.
Yes, we did a lot of customer survey around like the customers to analyze the customer sentiment, what they want to achieve in terms of automation, and it's significant. Basically, today when we looked at it, majority of the customers are working in a way that like manual or assisted systems or semi-automated way. Let's put it that way, and this is more than 60%, 68% actually. They are working in that kind of setup. But when we asked them by 2030, what do you want to achieve? And then 74% of them told us that they want to go to not 70%, let's put it this way. 68% told us that like they are working with manual assisted systems or semi-automated systems, so more humans in control. Then by 2030, 74% of our customers want to be automated in the sense that humans are for creativity more. And which means like highly automated cells. So you press the button, it runs 8 hours, 10 hours on its own. You load everything up. Or you have more robots on the shop floor. Basically, you have much more complex workflows. Robots are also included. That kind of automation, and a smaller portion, higher tier customers told us they want to do lights out completely. And this is today 1% lights out. And in our customers, 16% wants to go up to lights out by 2030 for certain manufacturing cases. So this is like a customer sentiment around automation. But how do you do this? So generative AI becomes very important to reach this, or AI becomes very important to reach these automation levels.
That's almost the assumption. I'm going to ask you what role AI is going to play, and I assume it's big. But one more question on your survey, and at the very end, I'm going to ask you for this global perspective. But already for the moment, is there any, when you say your customer survey, are those global customers? Are they mainly in Europe, US, elsewhere? And just one line answer on maybe any structural differences between where your customers are in what part of the world?
They were global, and they were a mix of like different manufacturers. So there were like aerospace manufacturers, automobile, small shops, die mold makers, and stuff like that. But majority, I would say, it was North America and Europe. They surveyed people because we are so big in North America and Europe as a company, and in Asia we are growing still. We are growing and we have a lot of room to grow. So this was a bit of the storyline, but it was very diverse customer base that we talked to.
So, assuming that AI is going to play a major role from exactly this, what you mentioned, humans in control, and then moving towards humans for creativity, as you call it. So the machines are going to be doing can we say, the boring stuff, maybe the boring repeating. It's not boring in itself for a human to produce one piece of whatever, I believe, right, over an hour or a couple of days, whatever it is, or a longer time, and then the humans concentrating more on creativity. So, what are going to be the structural differences between those phases, and how are they going to be driven by, or what role will AI be playing?
In this transition, you mean?
Right. Yes. I mean, assuming that it's I don't know. I mean, one is a view towards the autonomous lights out. That's the view. The other thing is the execution of it, kind of. And there's almost like an assumption that I'm asking you. Yes, is it being executed through Gen AI? Is the question, or is the assumption? I guess.
I would say it will be like having different colleagues around you, the feeling with Gen AI. So it's not maybe it is running it on its own, but it is more like assisting you, and you still confirm or modify things when you're interacting with it in the short, in at least in the short term or medium term. It will be like that. That's how we imagine it, and that kind of drastic change. Maybe there someone will invent new techniques that are reliable enough that we can leave it on its own. But it will be like more like you have different digital assistant colleagues around you for different purposes. So you are still for creativity, as you just touched upon. Human is there for creativity, but when you're problem solving, let's give a more human example. I'm on the shop floor. I have a problem to solve. I need to find Mike, who has 35 years of experience in shop floor. He has been there for since age 17, but he's sick, and I need to solve the problem. Gen AI can help us to capture the Mike's expertise, bit of it, and instead of reaching to that same information in 3 hours, 4 hours, I reach it to in 30 minutes. Or like I need to pick up context, learn something fast enough so that I can solve a problem. This can be programming an automation system, for example. Maybe learning it on my own will take a month in a reliable way. And with a Gen AI system, maybe I'll be able to pull this off in 3-4 days. For example, I'm on the shop floor, I need to program something. And then I created a Gen AI system that has a lot of automation programs in it. And it understands the industrial automation, like industrial programming languages, let's put it that way. And then you just solve the problem much faster. So you're still focusing on the productivity part, problem solving part, creative part, because you have much more information how things are interacting, and you're using your brain for that to create the architecture of the solution. And again, for knowledge labor parts, time consuming parts, sometimes you accelerate it with Gen AI colleagues. That's how we foresee it in our company at the moment.
And I guess others have come up with this term of the co-pilot, which you call Gen AI colleagues, which I'm not going to be promoting one or the other, but it's a term. It's a term that's out
Yeah, we do also label our assistant systems as co-pilots. So
there. You do as well.
yes.
As you were talking, I was thinking in my brain if the term has a trademark or a registered trademark.
No.
And if you say you're using it, then I guess there you go, Copilot. Yeah, I think it is a very good term. I just came off a long haul flight. Did I see? Yeah, sure. You always, when you're on airports, except for today in Germany because there's a strike on the airports. But there you go. You always see the the crews walking around. So you see typically the pilot, and I think many times they walk in sequence, right? The what is it? The commander, the first, and then the co-pilot behind. So we don't see them as we fly these days, unless you're in a very small plane. But yeah, I guess from that perspective, what you call the Gen AI colleagues, the co-pilot, is that exact idea. Now, I am actually, after this, I'm going to be doing another podcast interview on the very topic of humanoid robots, and I believe you have a perspective there as well. And when you say AI and humanoid robots, what is it, the dynamics that they're going to allow us, which we have not seen up until today?
Yes, this is like AI and humanoid robots, or this robotic technology shift, big shift that we are seeing right now, and they're kind of reinforcing each other's acceleration. It's one of the major shifts probably in technology history. We've seen maybe a thing that we can compare against. I wouldn't say that it's maybe exaggeration. We can compare this like with steam and invention of steam engine, as big as that, or democratizing the personal cars, automobiles, which created a huge shift from just horses to cars in less than 20 years. Big switch in US, for example. You didn't see any horses on the roads all of a sudden. And today, we are producing robots, but soon, with the help of AI also embedded into those robots will produce many things. And this is a big shift, and we need to be prepared. And this is nothing that we can escape. So this is coming. If it is coming, you need to embrace it and adapt, right? How we can make use of this new productivity jump to solve even bigger problems that we compared to what we have solved before. So it is so exciting what's happening, and we are going through it, and probably next 10 years, 15 years, this will be huge in terms of changes in our world when we look back, if we live long enough, of course. So this is the biggest shift. So this is a big wave that we cannot escape. That's why we need to embrace it. And our old systems needs to be redesigned. They need to have co-pilots first, but then in the long run, ditch all UX that we had before into something else, more to voice commands and things like that, so that we just tell software what we want to achieve, and it helps us to achieve there instead of clicking 50 buttons on it. So that's one perspective. But also on the shop floor, I want to achieve something, solve something. I focus more on the architecture of the problem solving, on what I want to achieve, and then the in between steps. So and this will happen with humanoids and AI, and this will happen very fast. It seems like at the moment. So this is like something fundamental. It's a wave that we cannot stop.
Do you see the humanoid robots play a role within the factory as well, or is it more like, in consumer space, so to say?
In factory, probably in certain factories, it will be used more. But as an engineer, if you are able to solve a problem in a simple way, you should always solve it in the simplest and the most reliable way. So the industrial robots will still be around because they are really cheap and very reliable in terms of their performance for years. And when it comes to humanoid robots, it's yet to be seen if you use them at scale, how reliable they'll be in terms of mechanics. Will they wear out too fast, or in what kind of applications we can use them more reliably? In what kind of applications we should still lean towards traditional industrial robots? So in normal life, definitely we'll see them, and in factories, depending on what they're doing, we'll see more humanoids. But we will definitely see humanoids on factories as well. So,
but I'm with you. As an engineer, as I am myself as well, try to solve things in as easy as possible way. So the example I would give is the Roomba, for cleaning the floor. It's flat, so it can go under your couch as an idea. So as an idea, why would I have a humanoid robot doing the normal cleaning of the floor the way that a human does it? But nevertheless, as you say, the reason I've heard many times is to say we cannot find people anymore. It's so difficult to find people. If we don't have people, then at least we can keep the factory as it is if the humanoid can represent the moves, the actions of the human. But if that is so, and I hear you say as well in specifications that may be the case, then that is, of course, at max transitional reasoning then. So having talked on the AI humanoids, do they encompass agents as well? Can you share some examples? If yes, and what does it mean for the role that is maybe left or not for humans?
I'm not an expert on humanoid part, but what I observe, what I read, it appears that there'll be a lot of agents will be embedded into them as well, or they will be able to interact with agents. So we will see that definitely.
But also independent of the humanoids, I mean, right? I mean, I think agents can be used independent of the solution being humanoid or not, right?
Yeah, exactly. Sorry, I misunderstood you then. Yeah. And yes, exactly. They can be used separately, definitely like that. And it like Copilot, like interact with, or like, let's say Copilot have multiple agents behind one Copilot, and then so it will interact with human, and it will kind of, if you know what questions to ask, then it will help you to solve things. So you still need to know things. So
it has been the same since Leonardo da Vinci, right? You know, he knew to ask the right questions.
Yeah. So it doesn't like reduce the worth of like asking good questions, and asking good questions often means that you need to still have a lot of fundamental knowledge and experience in your brains to be able to ask the right questions. And so from that fundamental perspective, yeah, we will interact with agents. Robots will humanoids will interact with agents, but our interaction with agents will be still much more creative, because and there'll be huge differences depending on who's asking the questions, or how you're asking the questions.
Yeah, as a close-off maybe on the topics of the of Gen AI and agents. I understand you have been thinking about an AI agent architecture. We don't want to go here to the details. I mean, people interested can be asking you later separately, but I think it's starting with a definition. So I'm not going to ask you for the one word, but what is then for you, what are the agents? What role are they going to play as part of or in combination with the Gen AI that we've been talking about?
Yes, in agents, in our Sandvik manufacturing solutions context, how we think of it is we have our software systems. They do different things. Some of them do measurements, metrology. Some of them creates this helps us to do the manufacturing process planning. How we assume there are different functions in this software that needs to be still executed. This can be like picking the right manufacturing parameters. This can be optimizing a manufacturing operation. This can be giving feedback to designer about manufacturability, because since we are a manufacturing process planning software, we can definitely give feedback around, okay, this is easier to produce than the other option, or here, these parts, maybe you need to modify. So we think of like different microservices type of thinking. So you have this different agents with different specializations, and one agent might be using different subsystems, software systems or algorithms or other AI systems that are deterministic, or like, as I said, AI systems. So like an agent can be talking to another AI system, or a software system, or an algorithm, like rule-based systems, and coming back with the feedback according to your question or what you're seeking. So this is how we think. Many agents, like microservices, around our products, and in the future, hopefully, we give them to customers also, so that they can use them on the shop floor, even if they are not using our products directly, or some of our products are used on the shop floor, but still to improve the connectivity around. So that's how we are imagining how agents will work. Is just this Copilot system, but support the Copilot system, but in a way simplifying the overall experience or increasing the productivity overall of experience of our when they're increasing the productivity of our customers when they're using our software solutions. So that's like a kind of how we are imagining the agents at the moment, but multiple agents. And since we think them of like in different pieces, so we want to introduce them, introduce more of them over time. That's kind of the thinking. So like a individual microservices, like you can think of them, and we will introduce many of them over the years, specialized on different things, and improve them over time. So this is like kind of roughly the thinking, and we are already investing a lot of time and resources into this to catch this. As I said, this is something inevitable. So this wave is coming. We need to embrace it to be future relevant. So that's what we are doing exactly.
Very good. Tell us about your team. Your team, together with Magnus Malmström, your CTO, we're going to be seeing soon in the Alps. Where are you based? Where are your colleagues based? Are you centralized, decentralized, other parts of the world? What type of jobs do they have? Maybe you're looking even for new colleagues. What should they bring?
We have brands like headquarters, different offices around the globe. We have office in India, Tel Aviv, for example. We have in West Coast, East Coast of US. We have an office in France and many other places because we have different products and the teams originated in those places. I am based with my team and the CTO also Stockholm based. We are Stockholm based. And our team constitutes of, it's like a cross-functional team, I would say. I am a mechanical manufacturing engineer as a background and got into digital manufacturing early on. First, like building digital machining solutions, and then still touching the digital machining space, but now with around manufacturing, how to implement generative AI and cloud systems. And in the team, we have software engineers, we have mechatronic engineers in our team. And then in the business units or like brands, I would say we have a lot of different engineers, also software developers, architects, and application engineers, product managers. So it's just like we work as a one team around this. So whenever we are focusing on something, is generally we bring in the cloud and AI expertise part into the game, and then domain knowledge comes from, or the product related knowledge comes from the brands, and we kind of work together to create the experience together. And then as we work, the upskilling naturally happens in our business units, in our brands. So people we work with also become generative AI practitioners or AI practitioners or cloud practitioners over time. So it's just a way of also spreading the expertise and knowledge. And our Magnus Malmström, our CTO, is like a executive sponsor around this whole, we call it collective intelligence, actually, in the company of this initiative. So using all of our brains together to solve problems to help our customers better. So this is kind of the setup. And it's highly cross-functional, our team structure. And we really work in a fast way, I would say. So we launched our first co-pilots in less than a year for 3 different brands under our umbrella. So that was not very common. That is not very common when you look at other companies in our world, in manufacturing world. So we have a different setup, a really different setup, quite frank, trust-based, cross-functional teams that are accountable with what they're doing, the hold accountable about what they're doing, but a lot of autonomy around how they move forward. And we have a good executive support and guidance about the goals, clarification from that level. And then as engineers, we kind of focus on, okay, how can we get this done? So it's fun to work with, but yeah, it's a bit different, I would say, than many other places.
In a positive sense, right?
Yeah, in a positive sense, yes.
So let's come to a close. At a 10,000 feet level, where are we standing? Where are we moving? AI, Gen AI agents, we talked about all of them out of Europe for a global market, United States, China, other places. We just heard from you. What is the future going to bring? How fast? Where is it coming from? What implications as far as the introduction of Gen AI in the manufacturing, specifically CAM world, is going to be?
This is still a lot of questions around compliance. Many people are afraid that AI is stealing information sometimes, for example. So communicating that it's not risky. That's one thing that it's a challenge. Like this is like making people, or like realizing people, this is a big shift and they need to embrace this. Otherwise, they'll be left behind in this wave. It's just communicating that is one challenge, I would say, at the high level at the moment. And also how to use the generative AI, increasing that awareness, how to use it best. That's also a challenge at the moment that we are facing. But we see, since the launch, we see good adaptation also. So I think this is changing so fast. It's like these challenges around it. People they're more and more understanding that this is something that will be their part of their life in the future and trying to embrace it. But where it will go, or can you rephrase that part, like soon where it will be, or like in medium term where it will be, like that kind of perspective you were asking?
Yeah, sure. Whatever you feel, and of course from the beginning, understand it that there's questions everywhere. Looking into the future is always very difficult. Just your personal perspective and what you see is going to be the major shift, the major changes in the world of manufacturing, and what that means to the world outside of maybe the production, the manufacturing facility as well.
Okay, from that perspective, soon, like in short term, we will see a lot of simplification how we use our software, and we'll see more productivity gains, or like making expert knowledge accessible to beginner level users or average level users. More expert knowledge, and experts still will be expert and very valuable in the short to medium term. So expertise still will be super valuable. Deep manufacturing expertise. But generative AI's initial benefits will be towards more to the beginner level and average level people, or smaller shops who doesn't have much access to expert knowledge. From that perspective, that will be the first implications that we see. And in medium term, we'll start to see this user experience simplifications around the manufacturing software also. Maybe not replacing the user interface, but more and more simplification of certain workflows in the manufacturing software. This will in fact impact the world in a way that we talked about design to manufacturing cycle time reduction, right? Like going design to manufacturing, how can we accelerate it? AI and automation is one of the answers. Or AI in combination with other engineering software, of course. And AI becomes the navigator there. But we'll see also maybe a positive impact on people efficiency when they are moving from design to manufacturing, increasing that speed in the medium term, because this manufacturability feedback tools will be more reliable soon, especially for certain types of manufacturing processes. So that will kind of accelerate this design to manufacturing cycle time, reduce that time. And on the customer side, for some types of manufacturing, probably will see costs are going down, the cost of making something. And this will maybe positively impact in the, not maybe immediately, but we'll see more distributed manufacturing, like more smaller shops, thanks to these technologies. Production will happen in a more spread out way than compared to before. So you'll see much more smaller manufacturing facilities spread out thanks to AI. Not immediately, but in the medium term. Highly likely we'll start seeing that as well. Because of since it simplifies many things, but also we need to take care of the world. So, and AI will kind of help with that as well. So these are the kind of what comes to my mind immediately. I improvised, so it's just thinking out loud. Yeah.
That's perfectly fine. The thing I heard you say most often, I believe, and that's for you, dear listener, there is no alternative. You need to embrace Gen AI, is what I heard you say a couple of times. I would strongly agree. Yeah, dear listener, I'm happy that you stayed with us so far. Looking forward to have you with us again. And Coskun, thank you very much for your perspective, for your sharing your experience in the CAD/CAM world with us, and showing your thoughts, sharing your thoughts on where we're moving. Looking forward to see you sometime soon, and have a good day. Good luck with your business. Thank you.
Thank you very much, Peter. Thanks a lot. It was my pleasure. Thanks for inviting me. Yeah.
Thank you. Bye-bye.
Bye-bye.